So question 10 is about forces and objects they act on, and also about interaction force pairs. So it says Jim pushes a heavy crate across the floor. 4 different forces act on the heavy crate. One of them is shown below, acting to the right. Force from Jim, there you go. So he's pushing it to the right. The force from Jim acts to the right. Describe the other 3 forces acting on the crate. Now, they've really hammered home the fact here that the force is acting to the right. There's an arrow to the right, and they've said again, acts to the right. They're trying to give you a clue about how to describe these forces. If you don't put the direction in for any of them, it's 0. Okay? It says each must have name and direction for one. So if you just write down the names of the forces, that is no marks. Whenever you're trying to do something and they're giving you an example in a question, you must try and mirror it as closely as possible. So the other 3 forces are, lots of people identified these correctly but then didn't get the directions. Friction to the left, trying to slow the box down. The weight of the box downwards. And the trickiest one is probably the normal reaction of the surface. They've just said reaction upwards, so the floor pushing up on the box. Okay, those are the 3. So whenever you describe a force, really try and describe what the interaction is that's causing it. So friction, weight, or reaction force, and the direction it's pointing in. And that way your description will be complete enough to get marks. And part B says Jim has a weight of 800 newtons. He pushes on the crate with a force of 200 newtons, giving it a steady speed of 0.5 meters per second. The crate has a weight of 400 newtons and a mass of 40 kilograms. So that's a lot of information. Okay, and it says draw one line to link the direction of the force on Jim from the crate to its correct size. Draw another line to link the size to the correct explanation. So we're talking here about the force on Jim from the crate. So we switched away from the force on the crate now, and we switched to the force on Jim. Whenever you have forces, you have to have 2 objects because your forces come from an interaction force pair. So whenever it starts talking about the other object, that should immediately clue you in that we're talking about interaction force pairs here. So that kind of highlights the fact that the explanation really has to be something to do with the interaction force pairs. So the force on Jim from the crate is the one we're looking for. Interaction force pairs, the forces are equal in size and opposite in direction. Okay, so it says here Jim pushes on the crate with a force of 200 newtons. So if Jim is pushing on the crate with 200 newtons and he's pushing to the right, then the crate must be pushing him to the left with a force of 200 newtons as well. If you've got one of the forces in the pair, all you have to do to find the other one is swap the objects and reverse the direction. So the lines we should be drawing are to the left 200 newtons and the force is half of an interaction pair. So all along the second set there. Several people tried to draw several lines here. These are confusing questions sometimes, but it does say draw one line to link the direction to the force and another line to link the size to the correct explanation. So you should only be drawing 2 lines in total. And it's left 200 newtons, force is half of an interaction pair.